Hello, I'm RJ the Scholar, and since you clicked on this video, I bet you want to learn higher mathematics. So in this course, MATH-0400, Introduction to Mathematics, I'm going to teach you the essentials of higher mathematics and the way to work with it. A question you might be having is, I know mathematics. I know essentials of mathematics. I did algebra, I did calculus, I did trigonometry. I think I'm well suited. Why do I need an introduction? So, higher mathematics is a bit different than the math you're used to. Except maybe if you did geometry in high school. So, higher mathematics does a lot of the same thing you've done before. We'll still have computations a bit. We'll still have to solve problems. We're just gonna be a little bit more rigorous about it. Higher mathematics, we want to do everything from first principles. We want to build everything from that. We want to have a solid foundation, and from that solid foundation, we want to make sure that everything we derive from that, build on that solid foundation, is sturdy too. We don't want to have flimsy buildings that if we build a little too high on one of them, our building's going to collapse. We don't want that in our mathematics. What we want is to have sturdy foundations, and we want sturdy buildings. Because if a building collapses, we're going to have to rebuild it anyways. So we want to make sure that we are not rebuilding buildings constantly because we don't have a rigorous formulation of mathematics. So, our course is going to be split into 3 parts. 3. 1, 2, 3. So, here's how it's going to be split up into. So, yeah. Let's see. Okay. So, part 1 is logic. And we'll go this way. So our first part is logic. And logic is basically our basics of mathematics. It's essentially introducing you to the elements of modern mathematics. It's teaching you how we can use statements and build up how we can work with statements, which are essentially the bedrock of modern mathematics. We'll get into this more in the first lesson, but I think it's very important. And part 2, proof. We're going to look at proofs. And those are essentially how we make mathematical arguments to show how our statements are true in math. I remember something like a squared plus b squared equals c squared. We'd have to... You learned that in high school, but I bet you haven't proved it. Or if you have, great for you. We're going to do a lot more of those. So, what's next is axiomatic set there. And this is the meat of the course. Meat and potatoes. Right here, we're going to define We're not going to define a set, but we're going to pseudo-define one. We're going to discuss axioms, which are assumptions in mathematics. We're going to teach you how to work with them. We're going to teach you how to develop the concept of all of mathematics. All of mathematics can be built up from this, and this, and this. All of modern mathematics. And we're going to build it rigorously. We're going to start from sets. We're going to work our way up to numbers. We're going to build all of our number systems from sets. We're going to build the natural numbers. We're going to build the integers. What are the integers? Basically, all the positive and negative numbers. Whole numbers. Like, negative 2, negative 1, 1, 4. Like, those are what the integers look like. We're going to build the rational numbers. All of the fractions. Every single one of them. We're gonna do them all in terms of set theory. And so I hope you're excited. I hope to see you on this journey. And I hope you have a great day. Learn lots of new things. Have lots of fun. And so much more. Remember to like, comment, and subscribe. Ring the bell, of course, because you gotta only ring the bell, or else you won't be able to see part 2 or part 3. And as always, keep learning. Alright, the Scholar, out. Whew.